This is Alpha Group from Calc 198 with group member Steven, aka Black Attack, and Sadok. Thank you for tuning in. My name is Isaac Oboku, and I will be your presenter for today's podcast. In the previous discussion, we focused on average velocity and instantaneous velocity and how they relate to the sequence and tangent line respectively. In this podcast, we will focus on limits and how it relates to instantaneous velocity. Instantaneous velocity is defined as the velocity of something at a given point in time. Hence, instantaneous velocity is the slope of the tangent line. Now you may be wondering what a tangent line is. A tangent line is a line that touches a curve at a point. This is because the slope of the tangent line, which is the change in y over the change in x, tells us how fast or slow something is moving at that specific time. Back to the topic, a limit can be defined in mathematics as the value a function approaches as an input or index approaches a certain value. An example would be the limit as z approaches y, f of z tells us what is happening, or the value as z approaches y. However, the limit of a function does not always exist. For a limit to exist, the value as the limit approaches the input from the right should be equal to the value as the limit approaches the input from the left. The limit is related to instantaneous velocity in the sense that it helps us to find the value of the instantaneous velocity sometimes. The instantaneous velocity does not always exist on a graph at some point in time. Thus, when that happens, we use the limits to help find the slope of the tangent line, which is the instantaneous velocity. The equation that relates limits and instantaneous velocity is given by the limit as z approaches 0 of f of x plus z minus f of z all over z. In summary, for this podcast, we talked about instantaneous velocity and how they relate to the tangent line. Also, we defined limits and explained how they relate to instantaneous velocity. I hope you enjoyed, and stay tuned in for more. Until we meet again, have fun with the calculus.